Hey guys, all right, problem 2. Estimate the molar heat of vaporization of liquid whose vapor pressure doubles. So the vapor pressure doubles when the temperature is raised from 85 to 100. All right. So what formula are we going to use? Well, we got the molar heat of vaporization, we got pressures and temperatures. So it's probably going to be natural log of P1 over P2 equals delta HV over R, 1 over T2 minus 1 over T1. All right, so I got P1, P2, T1, T2, delta HV, and R. We're looking for delta HV, right? That is the question. T's. T1 is 85. Oh, that's a highlighter. 85 Celsius and 100 degrees Celsius. Well, 85 degrees Celsius would be 358.2 Kelvin. And 100 degrees Celsius would be 373 Kelvin. All right, so now I like to write all this out. I actually had a physics instructor in high school physics teacher tell me to do this. And so when there's lots of variables, well, ours is not really a variable, but lots of variables, sometimes this is helpful. The vapor pressure doubles. So it was pretty clear what T1 and T2 are. We know what we're looking for. We know what R is. How do we get these? Well, all we know is it doubles. So if it doubles, it goes from 1 to 2. Or it could be millimeters of mercury. That's just more letters to write. It doesn't matter. It just doubles. 5 to 10, whatever you want to put. 10 to 20. All right, so now let's plug in some numbers here. Natural log. We have 1 atmosphere and 2 atmospheres. Equals delta H, what we're looking for, R. So our T's. T2 is 373. T1 is 358.2 Kelvin. And then delta HV. Oh, didn't go. There we go. Come on. There we go. Now, how do we solve for delta HV? Well, the first thing we're going to do is right there, the natural log. Let's do that. So then we get, if I do the natural log of 1/2, I get negative 0.6931. And the unit is canceled. Now, I'm going to do this. I'm going to write it out. Delta HV multiplied by, all right, 1 over our 373 minus 1 over our 358.2K divided by R. All right, do you see what I did there? I just moved the R over. And so now we can do this term. So I get negative 0.6931 equals delta HV multiplied by what does that term come out to be? Well, on top, I get 1.123 times 10 to negative 4 Kelvin's on the bottom, 1 over Kelvin, so Kelvin negative 1. I'm just going to keep R there. 8.3145. All right. And so now what do we do? Now I can take all of this. I'm going to move it over. How am I going to do that? We're going to take our 0.6931 divided by the 1.123 times 10 to the negative 4, Kelvin negative 1, that's 4, all over 8.3145 joules per mole Kelvin equals delta HV. All right, so in the calculator, hopefully we can do that in the calculator now, delta HV. You take your 0.6931 divided by, I would just divide twice in the calculator. Make sure you use the times 10 button correctly. I get 51,300 joules per mole, or 51.3 kilojoules per mole. So that's what I get for number 2.